Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 10.3, Quotient of Powers Property. And it can be found on pages 424 and 425. Okay, so let's take a quick review. This is our base, and this is our exponent. And the exponent tells us how many times we're using the base as a factor, or how many times we're multiplying the base. And it is said 8 to the 4th power. 8 to the 4th power. So we're talking about the quotient of powers property. Quotient means division and powers means exponent. So we're talking about division of exponents property. Okay, division of exponents property. So let's take a look at what that means. So we are going to be dividing powers with the same base. So dividing powers, dividing exponents with the same base. Now, yesterday, we multiplied exponents and we learned that we either added the exponents or multiplied them, right? So today, we're talking about dividing exponents. Division is the inverse of multiplication. So with multiplication, we added or multiplied. With division, we're going to be subtracting. So let's take a look at what this is. 2 to the 6th power divided by 2 to the 4th power. What is this telling us? Well, 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Over 2 times 2 times 2 times 2. Right? Okay, well, I know that these guys are going to cancel each other. And I'm left with 2 squared. 2 2s. So this is what's going on. There is an easier way to show our work. So what we're starting with is 6 2s. But we end up taking 4 of them away. So we have our exponent in the numerator minus the exponent in the denominator. And that gives us 2 to the 2nd power. So let's do another one. Let's take -7 to the 9th power over -7 to the 3rd power. So what this is, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3. 7 to the 9th power means we have -7 as a factor 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. -7 to the 3rd power means we have -7 as a factor 3 times. So these guys will cancel. And I'm left with -7 to the 1, 2, 3, 4, 5, 6th power. Now there is an easier way to show our work. -7 to the 9th power, -7 to the 3rd power. So we have -7 as our base for both of them to the 9th power. And ultimately what we're doing is we're taking away these 3 that are in the denominator. So I have -7 to the 6th power, which is exactly what I had up here. Okay. Now what happens when I have something like this? H to the 7th over H. H to the 7th over H. Well, this means I have 1, 2, 3, 4, 5, 6, 7. I'm multiplying 7 H's all over H. So my H's cancel, and I'm left with H to the 6th power. But how do I show that easier? There's no exponent in my denominator. There's no exponent in my denominator. Well, guess what? There is an exponent. It's just an invisible 1. We do have an exponent here. It's an invisible 1. So we have H to the 7th, and then we have our invisible 1 there. And that is how we get H to the 6th. Okay. I have x to the 7th over x to the 6th. X to the 7th over x to the 6th. X to the 7th minus 6 is x to the 1. Do we typically put an exponent of 1? No. Typically, we just write x. So I think the quotient of powers property is relatively easy. We have our exponent in the numerator, and we're subtracting the exponent in the denominator. As long as our base is the same, we have our exponent in the numerator, and we subtract the exponent in the denominator. Well, that's all fine and dandy, but how do we put this into use? How do we use this? How does this apply to algebra, you ask? Okay. Well, we have 3 to the 4th times 3 to the 2nd all over 3 to the 3rd. So what's happening here? Well, we have 3 to the 4th. This is 3 to the 4th times 3 squared. Here's 3 squared. All over 3 to the 3rd. Well, these guys cancel, cancel, cancel. And I'm left with 1, 2, 3, 3 to the 3rd. How do I show this in a simplified form? How am I going to show this in a simplified form? Well, let's use what we worked on yesterday. 3 to the 4th times 3 to the 2nd. My base is the same and I'm multiplying them. So this would be 4 plus 2 all over 3 to the 3rd. So that's 3 to the 6th over 3 to the 3rd. Now, this is what we just did today. 3 to the 6th minus that exponent in the denominator. 3 to the 3rd. So we're combining what we learned yesterday, the multiplication of exponents with the same base, with what we're doing today, division with the same base. Okay, so let's do another one. We have a to the 10th power over a to the 6th power times a to the 7th power over a to the 4th power. Now, there are two ways of solving this problem. I will show you both ways. So the first way kind of combines what we did yesterday. We've got a, since I'm multiplying these and they have the same base, it's 10 plus 7 over a 6 plus 4. So that's a to the 17th over a to the 10th. And then this is what we're doing today. A to the 17th minus 10, which gives us a to the 7th. Or we have a to the 10th over a to the 6th times a to the 7th over a to the 4th. I can deal with my fractions. A to the 10th minus 6 times a to the 7th minus 4. So here I'm dealing with my division first. Then will give me a to the 4th times a to the 3rd. And then this is what we did yesterday. We're multiplying and we have the same base. So this is now a to the 4th plus 3, which is a to the 7th. Here, I dealt with the multiplication first, then the division. Here, we dealt with the division first, then the multiplication. Either way is fine. Okay, let's do one more. A to the 3rd times b to the 4th times 5 to the 4th all over b to the 2nd times 5. Let's talk about what's going on here. We have a times a times a, b, 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 times 5 times 5 times 5 times 5. All over b times b times 5. So I'm just following this. I've got a to the 3rd power, which means a is a factor 3 times. B to the 4th power, so I have 4 b's, 1, 2, 3, 4, and 5 to the 4th power. So I'm multiplying 5 4 times. B to the 2nd power, I've got 2 and 5. Now these guys cancel. My b's cancel. I have a 5 that cancels. And what am I left with? Typically, we put our constants first. So this is 5 to the 3rd power times a to the third power times b to the second power all over, that's it. Those guys all canceled out. So it's 5 to the third power times a to the third power times b to the second power. Now, is there an easier way of doing this? Yes. A to the third times b to the fourth times 5 to the fourth, b squared over 5. Okay, I like to deal with my constants first. So this is 5 to the fourth minus 1 times a to the third times b to the fourth minus 2. So I have 5 to the third times a to the third times b to the second, which is exactly what we had up here. Now, in the textbook, you may actually have to multiply this out. 5 times 5 is 25, times 5 is 125. I don't know if they'll accept this or this. I'm not sure which. You may actually have to multiply that out.
Do we have to put it like in the correct order, or do we put it in the correct order?
Good question. I don't know. You'll have to play with it. I don't know if it accepts any order or a specific order. That's a good question. So this is what we're doing today.